We've already gone over students' t-tests for a single sample. That's the beginning of Chapter 7, but then it continues on to talking about t-tests for dependent samples. There are several things we can call this. T-tests for dependent samples, t-tests for paired samples t-test. All that stuff is real, and that all means the same thing. So here's the basic premise. You got before, and you got after. That's it. Once we subtract after from before, before from after to find the difference between them, we can assess whether or not this is different from what we would expect, given the idea that if we do something in between before and after, it may have an effect on this dependent variable that we're measuring. So we're measuring a dependent variable here, and we're measuring a dependent variable here. So, you guys want to go to Professor Frizzie's Basketball Academy? Let's play. Okay, we're going to teach you guys to shoot free throws. The first thing you need to do is you're going to shoot 10 free throws. We're going to get a baseline test. That baseline test is going to tell me how good you are compared to you, right? So I can't compare you to, say, Steph Curry or even Shaq. You might not shoot as well as Shaq. So we'll take your score on those first 10 free throw shots, and I'm going to take 5 of you. You guys come out here. We've got a little hoop outside. Go over there and just shoot some hoops. You guys will shoot 5 or 10 free throws, and the 5 of you, I'm going to mark you down here as your before. So there's 1, 2, 3, 4, and 5. Got it? Those 5 people are going to shoot 10 free throws. Now, of the 10 free throws, number 1, she hit 5. Number 2, she hit 2. Number 3, he hit 1. Number 4, she hit 5. And number 5, he hit 2. You don't know it, but in my spare time, I spend my time perfecting the free throw arts. And all I do is teach and modify and experiment on how free throws should be shot. I teach you a method to shoot free throws that's been the most consistent and the most effective ever known to man, and that's the underhand granny shot. That granny shot is what gave Rick Barry a competitive advantage. Will Chamberlain, who scored 100 points in a single basketball game, used to shoot free throws underhand, but he got too embarrassed to do so. He kept shooting overhand, and because he's a 7'2" guy, his trajectory was off, and he was a bad free throw shooter. When he shot granny and underhand, boom, he was better. So what's going to happen after you guys shoot your free throws is I'm going to teach you how to shoot granny shots. So this is Professor Frizzie's Free Throw Academy. So that's what happens right after before. I take you, I measure you, I then put you through my academy, and after my Free Throw Academy, you come back and you shoot 10 more free throws for the after. Again, this will be person number 1. Person number 1 hit 5 free throws to begin with. So if they come out and they shot 2 free throws like this next person, she would be no better. She would be worse, right? So what we're going to do is compare her to her. From her, she was pretty good at shooting free throws before the academy. Now let's see what the academy did to her. She got 8. Number 2, she got 7. Number 3, he got 5. Number 4, she got 3. And number 5 got 9. So, here's the question. Does Professor Frizzie's Free Throw Academy work to improve your free throw shooting such that you'll pay $59.99 to attend this 1 hour, I'm not going to do it for 1 hour, 20-minute lesson on free throw shooting the granny way? That's our question we're going to ask. And now we can ask that question with these 2 bits of data, the before and after. One of the tricks here is you think, oh, there's so much more than we had before. We only had a mean and a standard deviation. No, this is very easy. The book's going to tell you to do something, and if you like doing it that way, that's fine, but you have to do some mental gymnastics. Later, when we use SPSS to do this, you'll have to do it the opposite way. I like to take before, and then I subtract after from it. Now note, person number 1, she got 8 free throws the second time, so if we subtract a larger number from this, we're gonna get a negative number. Now, negative doesn't mean bad in this sense. So here's the difference score. The difference score is 8 minus 5. I'll have as -3. Okay? The second person will be 2 minus 7. That's a -5. Next person will be 1 minus 5, a -4. Next person will be 5 minus 3, which is a +2. And the next person will be 2 minus 9, which is a -7. Check it out. Those negatives, don't think of them as bad or worse. In fact, it represents that time 2, the person had a higher score than they did at time 1. So to assess the effectiveness of Professor Frizzie's Free Throw Academy, we actually want to have negative scores here because we're subtracting after from before. Now, if you do what the book says take before and put it after and then subtract before from after. It doesn't make sense to me. If you want to do it that way, that's fine. Then your positives will represent a change for the better in the free throw shooting capacity. And then this number will just be a 3 instead of a -3. So if you can get past the idea that the negative just means that they had 3 more free throws that they made out of 10 after Professor Frizzie's Free Throw Shooting Academy, if you can keep that negative actually means they got better, well then, you're fine. Okay, one more thing. We don't need any of that now. That can all go away. We don't need it. Don't need it no more. Why not? Now you might say, well, why don't you need all the scores? What, those scores tell us who shot what and when and how. Well, because a paired sample t-test, all we actually need are these difference scores. We're going to treat these difference scores like they're a single sample. And then we're going to put them through the ringer of a t-test to see how do they compare, how's the average difference score for this group compared to what the average would be before and after difference if Professor Frizzie's Free Throw Shooting Academy made no difference in free throw shooting. Whoop, I'm back, and I take those different scores and I put them over here. So same difference scores. Again, we had -3, -5, -4, 2, and -7. We're going to treat this now that we've done the difference measurements, we're going to create an average difference. So see what is the average difference between before and after Professor Frizzie's Free Throw Shooting Academy. First person had a -3, then -5, -4, 2, and a -7. When we add those all up, we get, I believe, 17 negative. Right, so that'd be -2 plus -3 plus negative. Yep, it's -17. You divide -17 by 5, and you get a -3.4. So our average difference score, the average amount of free throws that somebody got better was 3.4. Even though that's a negative, they got better 3.4. So, next thing we're going to do is we're going to subtract the mean, which is the mean difference score, -3.4. We're going to subtract that from all of them to create difference scores. Deviation scores from the difference scores, that is. So -3.4 we're going to take away from all of these. But again, when you subtract a negative, like this one right here, we're subtracting a -3.4 from a -4, which actually kind of means like we're adding towards 0. So we're taking -3.4 away from a -4, which means the only thing that's left is a -0.6 negative. Okay, so now we have all of our difference scores. 3 minus a -3.4 is 0.16. Okay, then we have, I'm sorry, 0.4. Excuse me. My bad. 0.4. -5 minus a -3.4 is a -1.6. -4 minus a -3.4 is a -0.6. 2 minus a -3.4. Remember, in this case, we're kind of like adding. So that becomes a 5.4. And then 7 minus a -3.4 is a -3.6. If you add these up, these are deviation scores, and the principal function of the mean is to make itself at one time equidistant from all of the scores in a distribution. Thus, 0.4 plus -0.6 0.16 plus a negative 0.6 plus 5.4 plus a negative 3.6 equals a big fat zero. Nada. Zilch. Niet. 9. I don't know if that's nothing, but nothing. We get 0. This again doesn't tell us anything about the variability of our difference scores, and that's what we want to find. Is we want to find the variability of our difference scores, specifically the sum of squares, so we can calculate an estimated standard deviation for distribution of means for our population of different scores. We'll get there in a second, but let's do the calculations. We know what we're going to do. We're going to square these different scores. Different scores squared, so 0.4 times 0.4, shout it out there in TV land, it's 0.16. If you know this one, that's really good. Negative 1.6 times a negative 1.6, 2.56. Wow, great. I didn't know you knew that. That's incredible. Good job. 0.6, negative 0.6 times a negative, or 0.6, again, cancels out the negative and makes a 0.36. Now, if you know this one, you've been doing some serious math at home. It's 29.16. I bet you didn't know that. I bet you didn't know that. Okay, and this one you might know, but that'd be super crazy. Okay, it's 12.96. Okay. Now what we're going to do is add all of these up, because when we add up the deviation scores that are squared from the mean, we get the sum, adding up, of squares. Sum of squared deviations from the mean. The sum of squared deviations from the mean is 45.2. We know sum of squares is 45.2. That's all we need. We don't even need this anymore. We'll keep that in mind, that negative 3.4. That's going to come in handy here in a second. And we're back here doing our paired sample t-test. We're trying to figure out if free throw shooting class with Professor Frazee, my free throw shooting academy, makes people better. We saw that they had on average, the 5 people that did the test, they got on average a negative 3.4, which actually means that they improved the second time. That is after they took my free throw shooting academy. What we don't know is how much we expect people to vary on the free throw shooting technique. So if I took you out here again, let's say I took 5 of you out here and had you shoot free throws, and then a week later, I did nothing. I didn't tell you to shoot free throws, I didn't teach you to shoot free throws. I take you out here again and I ask you to shoot those free throws again. Would you shoot the exact same amount out of 10? Of course not. You would make, even NBA guys, they differ from one week to the next in terms of what they do. Now, they're much more consistent. Their variability is much smaller in that population. But if you went out there, you'd have some variability. So we took our sample's variability, and now we're going to put that onto our comparison population. 2 groups of people, right? Let's start off with number 1. It's 2 populations. Population number 1, we'll say, is people in general. People in general. Population number 2, this special crew have taken Professor Frazee's Free Throw Shooting Academy. Special people that they are. Now, our null hypothesis, and even though I am the head proprietor of Professor Frazee's Free Throw Shooting Academy, I've developed the techniques and the training methods, the curriculum, the assessments, the advertisements, the marketing, and all. I still know that we have to start with the null hypothesis, and that comes with the idea that my Free Throw Shooting Academy might not be any different from people shooting free throws in general. So, how do we represent that? Population number 1 is equal to population number 2. This is possible. And in fact, we're going to calculate the probability that that's true. Our p-value, when we get to our t-critical value, and if our t-value that we obtain from doing this work is more extreme than that, then I'll be sure that this is not true. Or at least very confident, 95 or 99% confident that this is not true. What I think is true, why I've spent all of these years hustling, dedicating myself to the art and craft of teaching free throw shooting, is that I believe my Free Throw Academy can make Population 1 better if they become Population 2. That is, that they take my academy. Look, you either have taken the academy or you haven't. So there's two groups of people in the world. I think the group of people that have taken my academy will be better free throw shooters than those who haven't. This is step 1 of hypothesis testing for paired sample or dependent sample t-tests, whatever you want to call it, before, after. Step 2. Now, we did all that math before. You can't even see that step 2 here. Hold on. Step 2. There it is. Determine the characteristics of the comparison distribution. What we're going to do with this is we need to find, well, what's the mu for the distribution of means if nothing's different, right? Because the comparison population is going to be those folks. So what would their average difference be if there's no difference from time 1 to time 2? And this is a tricky one, but check it out. If there's no difference, if my academy makes no difference, what would be the average difference shooting free throws 10 times 2 weeks, or a week apart, 2 times a week apart? What would be the average, right? Some people would by chance shoot better, some would by chance shoot worse. But if chance is acting alone and they hadn't done anything to improve their free throw shooting technique, what would the average difference be from week 1 to week 2, from before to after? If nothing happens in the middle, what would the average difference be? If you're thinking 0, you're right. That's exactly correct, because if there's no difference, yes, some of the individuals are going to get better by chance. Some of the individuals will do worse by chance, but what's really cool is those two things will average out over the law of large numbers. The larger the sample, that will average out. And if there's no training, if there's no difference from time 1 to time 2, then we're not going to see a difference, and the average difference will be 0. So our population that we're going to compare our group to, the group who takes Professor Frizzie's Free Throw Shooting Academy, we're going to compare them to a population that has an average difference of 0. Now, that doesn't mean nobody shoots any different from the time they first did. And that's why we have to come up with the second one, which is S sub m, or the standard error of the mean, the standard deviation for the distribution of means. Okay, we did that. We calculated that last time by taking the sum of squares. Sum of squares we saw was equal to 45.2, and we divide 45.2, right? We divide that by n minus 1, and for our case we only had 5 people, so it's a pretty significant change to this. So 45 divided by 4, because we had 5 people do it, so 5 minus 1 for a degree of freedom. The n minus 1 is a degree of freedom. That equals 11.3. Now that is our S2, or unbiased estimate for the variance. But we need to get S2 sub m, and to get that we take S2 and divide it by n. So our S2 is 11.3 and our n was 5. You can't see any of this. There we go. 11.3 and our n was 5. That means that this is 2.26. That is the variance for the distribution of means of groups of 5. But to get to here, we take the square root of it, right? And when you take the square root of that, it'll give you S sub m, or 1.503. Let's just say 1.50 for fun, just so it's easy to remember. What does 1.50 mean? When we did this math, we did all those deviation scores and square deviation scores, getting sum of squares. What does that 1.5 mean? It's simple. It means if you have a group of 5 people, the average difference that they'll have from time 1 to time 2 in free throw shooting is 1.5. That's the standard deviation for groups of 5. The average amount an individual will differ from the mean of their group. The mean will be 0, right? Because nothing's changed from time 1 to time 2. But individuals, they might differ 1.5 to the bottom or 1.5 to the top. Remember, 7 out of 10 people are gonna be within the absolute value of 1.5 from their previous week's shooting. So that's what helps us there. Also, now we can draw out a distribution. I'm gonna get rid of this, and I'll be right back. Coming back at you. We've got first step done, population 1 and population 2, HO, ho-ha, and the mean for the distribution of means, which is 0, because if there's no difference from time 1 to time 2, the average difference will be 0. But we know there's variability in people, and we calculated that with all that extra work to find that S sub m is 1.5, or the average person will differ about 1.5 free throws more or less. Remember, standard deviation can go both ways on that curve. So we're going to draw out now the curve. We're going to draw out our comparison distribution. So here's our comparison distribution. Our comparison distribution has a mean of 0 because if there is no difference in Professor Frizzie's free throw shooting academy, the average outcome will be 0. But we know this standard deviation for the distribution of means means that will be minus 1.5 for one standard deviation below the means, or minus 3. I don't like that when you put the point zeros after there. You know what minus 3 means. Or positive 1.5 or positive 3. Those are the potential raw scores for us. Now, what did our students do when they went out and shot free throws and then took my academy and then did it? If you forgot, we'll get to it in step 4, but you can go back and watch the other video and find out what their mean increase was. Hint, they got better. But did they get better enough to suggest that there's a statistically significant difference? If you take Professor Frizzie's Free Throw Shooting Academy, we're going to have to figure out where we would reject the null hypothesis. Now, look, I don't think anybody, you might be reasonable in claiming that my Free Throw Shooting Academy did not make an improvement in shooting. But nobody in their right mind would claim that I made people worse at free throw shooting after having spent time with me learning the techniques of free throw shooting. So, if you think about this curve, if you got worse, you'd be up here, right? Because the after number would be larger than the before, so your difference average would be up in the positive. But if you get better, the second time, your number for free throws will be larger, and so you'll have a negative score. So now when we think of t-scores, 0 t-score, negative 1 t-score, negative 2 t-score, right? This is a 1 t-score and a 2 t-score. Okay, we need to now figure out where on this cutoff are we going to reject the null, and that is step 3. Step 3. This is a one-tailed test because everybody only believes that you could get better or no difference. Nobody believes that you're going to get worse taking my academy. One-tailed test, 0.05 alpha. And so now what we do is we turn to the back of our books. I can't find my book. Found it. Turn to the back of our books and we take our sample size. Now, our sample size was pretty small, I'm just saying. But our degrees of freedom was 4. This is a one-tailed test and we're using a 0.05 alpha level. So for us to reject the null hypothesis, you'll see the critical value on page 675 for 4 degrees of freedom, one-tailed test at a 0.05 alpha is 2.132. Ours is a negative 2.132 because that's the direction we're predicting the change of this independent variable, whether you take in my class or not, is going to move the dependent variable, your free throw shooting. So if you get to a negative 2.3, I already forgot it, that amount of time. Negative 2.132, so just right here. If you get anywhere worse than that, that's an improvement in free throw shooting. Anything more extreme than that, then we're going to be able to reject the null hypothesis that my free throw shooting students come from the same population as everybody else, meaning that there's no difference in the free throw shooting academy. So, step 3, we've determined our T critical value is negative 2.132. Now we move on to step 4. I'll put step 4 up here. If you don't remember, maybe you don't, our students got a mean difference of negative 3.4. Now, what does that mean in terms of t-score? Well, we're going to have to calculate a t-score to compare it to a t-critical value. Okay, so let's get rid of the top part of this curve, and I can use some space here. That curve still exists. Our t-obtained statistic, the t-value that we get, is equal to mean minus mu divided by standard deviation for distribution of means, or S sub m. I'll bring you guys in close here. You can see how it is. So our mean was negative 3.4. We subtract that from 0. Now 0 because if there's no difference, the mean difference is 0. And we know that there is some variability, so we had 1.5. So if you take, let me get here, handy dandy calculator out, and 3.4 negative divided by 1.5, we get a t obtained statistic of a negative 2. This is where it gets exciting. 26 extending for forever. Where does that put us here? Well, we only needed to get to a t of negative 2.13, but we got to negative 2.26. So we're just in that area. We just made it. So I can claim that Professor Frazie's Academy worked. So step 5. Step 5, we're going to reject the null. Now in rejecting the null, that is over here, the null hypothesis suggested that there was no difference between population 1, that's people in general, and population 2, that's people that have taken my free throw shooting class. Step 6, you should say basketball players should sign up for PFFTA. PFTA.